So this one should be quick, just so you know. So if you're struggling, check out the note that I put up there. Okay, so before you add any base, you're just talking about a strong acid. You don't have to do any dilution because it's already just its own solution. And all of that, because it's a strong acid, gets converted to H3O plus. So all you have to do is take the negative log of 0.105, okay? Now, like I said, we won't do weak acid titrations, but you could do just a pH calculation of a weak acid, you know, like we did in chapter 17. That's where you would be using an ice table. Okay, so this pH comes out to be 0.979, which makes sense. It's a strong acid, it's gonna have a really low pH. Okay, next question. Calculate the pH after the addition of 12.5 mils of 0.13 molar NaOH. Okay, so I'll leave the work on that one up there and then the new question down there at the bottom. And on this one, I'll give you some guidance after a minute or two. And this one will definitely be a lot longer. Multi-step problem here.
Would those directions you gave be helpful for if we have a Pearson problem that gives us a weak or strong acid?
Well, so the ones on Pearson that are titrations with a weak acid, those are the ones I gave you the answers for in that PDF.
Okay.
So don't bother working them. Not worth your time.
Yeah.
Yeah. If it's, I guess you already did the chapter 17 homework, so you don't have to worry about that.
Yeah.
When you do the chapter 17 practice test, that's where you'll have questions like just what's the pH of this weak acid.
So where's the PDF? Is it like on Pearson?
No, I emailed it to you.
Oh.
I emailed it to everyone on Wednesday. Yeah.
Oh yeah, one of those you gave, I actually sent an email about one of them.
You did?
Yeah, because one of them I thought was 6.62, but it was 8.30 in Pearson. So I was.
Oh, yeah, I see it. When did?
Yeah.
Oh, it was yesterday. Yeah.
Yeah, and I like showed the work and stuff I did. Yeah.
And that was a weak acid titration?
I think.
Okay. Just go back in your email now and see if you can find the PDF that I was talking about.
Yeah.
Yep, that was a weak acid titration. I'm looking at your work now. Yeah, don't waste your time on those
Yeah.
because they're not going to be on the exam, so.
Yeah. Of course, I didn't know that ahead of time.
Well, you did. There was an email on Wednesday.
Yeah.
You just have to keep up on that. We did talk about it in class, too.
Yeah. Or well, what was happening is I was working on it with a tutor, so I could just tell her like, oh, I don't think I'm doing this.
Oh, you can tell them that kind of stuff. All right, so steps, you're going to do the dilution first, then you're going to do the consumption step and figure out what the final amounts are. So I'll work through that up here. Remember, for these dilutions, if you're adding 2 volumes, which in the titrations you always will be, you're going to be doing M1 V1 over V2 to find that new molarity, V2 being the total volume. So for the acid, 0.105 and 24 mils, and then the new total volume is 36.5. Whereas for the base, it's 0.13 and 12.5 and a total of 36.5. So this will give you kind of your starting points to do that consumption step. So when you get to that, you see that the base is smaller, and it should be because you are before the equivalence point. Before the equivalence point, and you don't know this till you do it, I guess, but before the equivalence point, you're having all of the base that you add gets consumed by the acid, so you would expect that to be smaller. If it's after the equivalence point, all of the acid would be consumed, and you'd have leftover base. Okay? So you always subtract the smaller one. And I don't even bother to write anything on the product side because it doesn't matter. It's not going to affect the pH at all. Okay? Just leave that empty. So now, because you only have acid left over, it's just like the first problem now, but now you have a different concentration. So the pH is the negative log of that 0.024. So 1.62. So it's gone up a bit, 0.9. Now it's up to 1.62. So we still have a ways to go before the equivalence point because we got to get it all the way neutralized. So that's the next question, is you're going to calculate the pH. Sorry, not calculate it. You're asked what the pH is at the equivalence point, and then you need to calculate the volume of that NaOH that's required to get you to that equivalence point. Okay, so I'll leave that work up there. Go ahead and start on this next one.
questions 2 and 3 include KAs, which is why they were weak.
Yeah. Which you'll have problems with a KA, but not a titration, right? You'll have buffer
Yeah.
problems, you'll have, just straight, here's an acid, what's its pH, just not a titration with that.
Yeah, it's like hard for me to notice those little details sometimes.
Yeah.
If the problem straight up tells me if it's a weak acid, then I'd be like, okay, well, yeah. But,
Yeah.
yeah, I guess they want you to know that, though.
Yeah, you should, because remember, you can always look at your list. There's only 6 strong acids: HCl, HBr, HI, and then sulfuric, nitric, and perchloric. Okay, remember that the key point of equivalence point is that the moles of the acid equal the moles of the base. Okay, so when you know that moles acid equals moles base, this is when you use that equation that looks like the dilution equation. It's just now molarity of the acid times volume of the acid, because that gives you moles acid. Okay, so plug in those concentrations, you get that the volume of the base is going to be 19.38. Meaning that once you've added 19.38 mils of base, you've now hit the point where you're completely neutralizing them. So you have the same amount of acid as base, they neutralize each other, and all that's left is water, so the pH has to be 7 at this point. Neither one of them is in excess, is another way of saying that. Okay, so the last question here is after the equivalence point. We only know that it's after because we just said that the equivalence point is at 19.38 mils, and now we're at 42 mils. So we've done a lot more NaOH adding. So we know the pH should be above 7 because we know there's excess NaOH here, but we have to figure out what it actually is. So we're going to do the exact same thing we did in the second one: dilution, consumption, calculate the pH. It's just that now the smaller amount is going to be the acid. So that's the one that'll get used up all the way, and there'll be base left over. Okay, so let's start on that. does that look different? 0.10. 42. I don't know. So the only kind of difference here is you've got to remember that now, because you have base left over, you're going to do the negative log of that concentration, but that's going to give you POH, not pH. Okay.
So, let me get this straight. I think the left side's the acid dilution, and then the right side's the base dilution.
Yeah.
Yeah.
Mm-hmm. I just do them right under the chemical so it's clear. And then same thing with the consumption step, it's right under it. So all of this stuff is for the base. All right, so now's the time to ask any questions about these titration problems. That's the last set of them that we're going to practice. Not that you don't have time, but Sunday is the homework for this section. And then, I was going to check that due date. And then on Monday, you can come in and work on the practice exams or work on them independently. And then the practice tests, I'm going to double check on what I had the due dates on those. I'm going to leave it as Wednesday because you guys have the exam on Thursday. Although I sure hope that my other classes are not dumb enough to try to not do the practice exam before their test on Tuesday and Wednesday. So you guys are Thursday at 10:30. Yeah, Wednesday. So the practice exams are Wednesday night.
And to be honest, that feels like a turn me from now.
It does, I know. That's quite a while.
Yeah.
Almost a week till the exam itself, for you guys at least. If you are just dying to take it early, I'm always fine with people taking the exam early. So if you don't have another exam scheduled, you could come take, you just need to email me so I know you're coming. Tuesday at 11, so if you want to write this down, it's in the email too, I guess, the 3 times. But because you guys are the Thursday class, I'm always fine with the later one going early, just not earlier ones going later, or else everybody would be in here. So Tuesday at 11 is a possibility, or Wednesday at 9. Okay, so if you want to take it early, just send me an email. Let me know which one of those. The Wednesday one is in here. The Tuesday one is downstairs. I think it's Hale 204, like same spot, but just across the hall. So just send me an email. Okay, so I put one more problem on here for today. It's a buffer problem. So it's just handwritten. You'll have to copy it into your notes. So you're going to start by finding the pH of this buffer solution, and then the second step will be adding a base, a small amount of base to the buffer and seeing how the pH changes. Okay, so the first direction I want to give here is recognize that it's not already a solution with 2 molarities. You have to do a little bit of work to get to that. So you need to find the molarity of the A minus, which is this 10 grams dissolved into 200 mils. The HA, you already know its concentration. This is not a dilution because you're not mixing 2 volumes. You just have to find the molarity of the sodium acetate by converting it to moles over liters to get the molarity. Okay, so before you can do anything else, you need to find that molarity. Over here. And then after you've gotten that, you're going to do the Henderson-Hasselbalch equation to find the pH. Not molar. That's moles. Then we're going to divide by liters to get molarity. Yeah, that's probably just going to take practice. Remember, HA is the acid, A minus is the conjugate base. So you need to look at the 2, and whichever one has the extra hydrogen, that's your HA.
Yeah.
And it's important to get familiar with that because that's how the equation is written.
Yeah.
And so it's not always specific to, a particular acid or base.
It's like, I know it's how it's written in general form, but like when you see it like that, it kind of throws your brain through a loop.
Yeah.
I don't know why.
It's okay. Just more practice. It'll come.
Yeah.
So 4.53 for the pH of this buffer before anything else has been added. And then the second part, I'll just leave it like this so you can see the question. We're going to add 10.3 mils of a 0.9 molar NaOH solution. And you need to figure out then what the new pH is. So it's going to go up slightly, but not a bunch, the way it would if you just added NaOH to water. So this is dilution, consumption, and then the Henderson-Hasselbalch equation for equilibrium. So I'm going to start in on those steps for question 2. Sorry, I realized you have to get the numbers up here. So it's 1 molar HA 0.610 A minus. So I'll switch colors. Step 1, dilution is in blue. Now I'm doing the consumption step. Then finally, I'll do the equilibrium step in blue again. Hang on, I did something wrong here. Oh, I subtracted. Okay. I feel like that exact same thing happened last class, where I subtracted instead of added. Maybe I'm making it up. Maybe it's just deja vu. There we go. So pH goes up a little bit. It was 4.53. Oh, is it really that small? Anybody have a answer already? Yeah.
I got the same answer too, but I did it like different.
But you got the same answer?
But it's like very.
I'm just not convinced that's right. Let me see. No, I don't have that written down from. I'm gonna have to double check it because it seems too small to me. let me just go through it real quick. 5.1, 10.3 times 0.9 over 210.3, 0.44. Oh, I did not do that again. It's actually. I feel like that's going to make it less, but maybe I'm wrong. That doesn't make any sense. That's actually going to drop it. Plus log 552 divided by 0.07. All right, something is not right here. I'm going to have to go back to this one and make sure. If anybody notices where my error is, let me know. That I'm pretty sure is right. Fifth log of 6.1 over 1, 4.53. Okay, that one's right. NaOH to A minus. That is not, that's where the issue is, I'm sure, but I'm still going to keep going through and making sure. 0.907. No, I'm still getting the same answer. I just thought that it was higher than that. Like,
The process is correct.
yeah, no, it is. My memory from last class is what's holding me back. I just thought that it was higher than 4.58. That seemed like a small change. I mean, 10 mils is not a lot. I'm just stuck on my memory from last class. So the process is right. It looks like the math is right. I just think it looks too small. Oh well, I'm probably just remembering wrong. All right, Monday optional. I'll be here. You can work on practice exams. Let me know if you want to take the exam early for any reason. And yeah, that's it. Homework, practice exams by Wednesday.
How many questions on the exam?
Same as always, 20. Yeah,
Okay.
yeah. And the exam starts at 10:30. That's just because the final exam schedule has like a half-hour break. So if you come at 10, there might still be other people in here. So we start at 10:30. All righty. Good luck studying.
grades are moving my exam up, but I have other classes with finals.
No, that's fine.
Yeah. I think that would cause too much chaos.
No, it's not necessary. It's just some people will like only have a couple exams and they're like, I don't want to have to stay on campus till Thursday, you know? So,
I don't know, maybe some students think 3 exams is not much, but I'm not one of those.
well, and a lot of people will have like papers, but not tests, you know, like they'll have a paper due, so then they get it done early. I
Yeah,
don't
that's
know.
true. Yeah, I feel like every semester's different. Like last semester I only had 1. This semester I have 3. Like, because some courses are set up differently.
Yeah.
It's so weird.